Today in Algebra 2, Section 2.2, we are going to look at slope and rate of change. The slope is rate of change. Okay, slope means steepness, and it's expressed as a ratio, and a ratio is just a fraction of the rise over the run. For example, if you have a skateboard ramp, and let's look and say that this is the ground, okay, this is going to be the ground, and we're going to have this ramp that goes up, and it has to be braced off on the bottom here. From the bottom of this ramp to the end, we're going to say that that is 54 inches. And it is 15 inches tall. Okay, so we can say that the 15 inches is how much it rises, it's how much it goes up. And the 54 inches is how much it runs, it's how much it goes across. So if we were going to find the slope, it is the rise over the run. The rise is 15 over the run, which is 54. That's our slope, and we can reduce that to 5/18. Okay, you want to keep your slope in a fraction if at all possible. If a line rises to the right, it is said to have a positive slope. If a line falls to the right, it is said to have a negative slope. If a line is flat, its slope is said to be 0. If the line is vertical, then your slope is undefined. This is very important, and I would know this for a quiz, and I would also know this for the rest of the year because it will make your life much easier. Hint, hint, could be on a quiz. In algebra, the letter M represents slope. When you are given two ordered pairs, there's a formula to find slope. Slope is y2 minus y1 over x2 minus x1. You can use this formula when you're given two ordered pairs to find the slope between the 2 points, or if you have 2 points on any line, you can do it that way as well. If we have the ordered pairs -2, 1 and 3, 5, we can use this formula to find the slope. Okay, so we have the slope equals y2 minus y1. The key to being successful using this formula is to label your ordered pairs. So we're going to make this x1, and the 1 can be y1, which will make this set the 2's, x2 and y2. Now, you can switch these ordered pairs and make the first set y2, x2 and y2, and the second set x1 and y1. Whichever x you use to be your 1, its y value must also be the 1. You have to maintain consistency in that. Now let's substitute the numbers into the formula. y2 is 5. 5 minus, what is y1? Well, it's 1. Over x2, which is 3, minus x1, which is -2. Okay, so now we are going to simplify the numerator. 5 minus 1 is 4. And then 3 minus -2 turns into addition, so that's 3 plus 2, which is 5. So the slope is 4/5. Now remember, slope can also be defined as the rise over the run. That means that between the 2 points that it must rise 4 units and run 5 units. To check this, or if we already had it plotted on a plane, we could count the units between. So let's do that now and see what we get. Okay, we have the ordered pair -2, 1, and we have the other ordered pair 3, 5. Once they are plotted on the coordinate plane, we can draw a line in between the two if we want. Okay, now we're going to start at our first ordered pair, -2, 1, and we're going to count how much did it rise. 1, 2, 3, 4. So the rise was 4 over the run, which is 1, 2, 3, 4, 5. So we can say that the rise over the run was 4 over 5. Either way you do it is perfectly fine. You may plug it in the formula and do y2 minus y1 over x2 minus x1, or you can plot the points and count the rise over the run. Either way that you do it should get you the same result. Okay, now we're going to practice finding the slope of lines. Okay, we're going to use our formula, m equals y2 minus y1 over x2 minus x1, and we're going to substitute these values into the formula to find the slope. So here's a y value and here's a y value, and we'll make these our 1's, x1, y1, which will make these our 2's, x2 and y2. Okay, so here we go. Y minus y, y2 minus y1. 1 minus 1 over x2, which is 0, minus x1, which is negative 5. Okay, so when we do that, 1 minus 1 is 0, and 0 plus 5 is 5. So the slope is 0. Now remember, on a previous page, we said that if the slope is 0, that means it's a flat line. So let's see if when we plot these points, it makes a flat line. Negative 5, 1 is at this point on the graph, and 0, 1 is at this point. If we were to draw a line between the 2 points, yes, it is a flat line. It has a slope of 0. A flat line has a slope of 0. So let's see what we know about what we can see. The flat line, 0 slope, has the y values that are the same. So I think that is something that is going to be very important for you to remember. You might want to write that down. When the y values are the same in your ordered pairs, your slope will be 0. Okay, it will be a flat line and you will have a slope of 0. Let's look at the second set of problems. We have the ordered pair 4, 6, and 4, negative 1. Again, we're going to use the formula y2 minus y1 over x2 minus x1. So we'll call these our 1's. The first set we'll call our 1's. And the second set we will call our 2's. Okay, y2, negative 1, minus y1, which is 6, over x2, which is 4, minus x1, which is 4. Okay, so we're going to have negative 7 over 0. All right, well, that's a problem because 0 in the denominator is undefined, so this slope will be undefined. On the previous page, we learned that a vertical line had an undefined slope, so now we're going to plot these points and see if we do get a vertical line. So here is 4, 6. And we need 4, negative 1 also. And you can see that it is a vertical line that can be drawn between the 2 points. And a vertical line has undefined slope. Now, I want you to notice the x values here. The x values on this are the same, 4 and 4 here. So, when the x values are the same on the 2 ordered pairs, you have a vertical line and it is undefined. Okay, another important thing, okay, that like we just said on when the y values are the same on this graph, okay, we get a flat line and a flat line is 0. When the x values are the same, you get an undefined slope, which means you're going to have a vertical line. Important, important, important. Take notes on that. Write that down, please. Let's do 2 more examples of finding slope when you are given 2 points. Okay, we are going to use the formula m, which is our slope, equals y2 minus y1 over x2 minus x1. Okay, we're going to plug in our y values and our x values here. y2, negative 4, minus y1, 0, over x2, which is 2, minus the x value is negative 6. So, negative 4 minus 0 is negative 4. 2 minus negative 6 is 8. Negative 4/8 is equivalent to negative 1/2. If you will remember on one of the previous pages, we said that if we found the slope was negative, then that means that line would be falling to the right. So let's plot these points on the coordinate plane and see if that statement holds true. Negative 6, 0 is located here. And 2, negative 4 puts us here. Now, if we were to draw the line between those points, then we would see, yes, that line is going down to the right. Okay, we can also count the rise over the run. So, if we do that, if we start at the point negative 6, 0, we can see that we are going down. So that's negative 1, 2, 3, 4. So the rise is negative 4. Over the run would be 1, 2, 3, 4, 5, 6, 7, 8. Over a positive 8. And that is what we got here. Okay. Now we said that reduced to negative 1 over 2, so let's see if that also works. Okay. Again, if we start at the ordered pair, negative 6, 0, we can go down 1, negative 1, and then positive 2, and that falls on the line, and so that is the same slope. Negative 1/2 is the same as negative 4/8. It's negative, therefore we know it's going down to the right. Pretty important stuff right there too. If the slope is negative, the line will be falling to the right. The last example that I want to look at has the ordered pairs negative 1, 3, and 5, 8. So again, we're going to use the formula m, our slope, equals y2 minus y1 over x2 minus x1. Okay, y2 is 8 minus y1 is 3 over x2, 5, minus x1, negative 1. Okay, well, 8 minus 3 gives us 5. 5 minus negative 1 is 6. That's 5/6. Now let's plot those points and see what kind of line we get. This is a slope. That number is positive, which means it should indicate that the line should be rising to the right. Let's plot the points and see if it does. Negative 1, 3. And 5, 8. Okay, we draw this line, and yes, it is rising to the right, so it's good. Now let's count the rise over the run. Starting at the point, negative 1, 3. Does it rise 5? 1, 2, 3, 4, 5. Yes, it does. Now does it run 6? 1, 2, 3, 4, 5, 6. Okay, so yes, it's rising to the right, and yes, the slope is rise 5, run 6, and you hit the line. So it's all good. Parallel lines are denoted with two lines that look like this, and that is how you denote parallel lines. What do we know about the slopes of parallel lines? They have to be equal, exactly equal. So the slope of one line has to be exactly equal to the slope of another line in order for the lines to be parallel. Perpendicular lines are denoted with an upside down capital T, and that shows that it's a right angle right there. So perpendicular means two lines that intersect to form a 90-degree angle. In the case of perpendicular lines, their slopes will be opposite reciprocals. Let's see what that means. If the slope of a line is 2/3, then the slope of the line that's a perpendicular line is opposite. So if 2/3 is positive, we're looking for a negative, and the reciprocal of 2/3 is 3/2. Okay, one more example. Say that the slope of a line is 4/7, then its opposite reciprocal would be negative 7/4. Okay, the other thing that you know about the product of the slopes of perpendicular lines is that when you take the product of them, which means when we multiply them together, that the product will always be -1. Because they are reciprocals, a number of times it's reciprocal is always 1, and if you throw a negative in there, then it just makes it -1. So let's try that. 2/3 times -3/2. Okay, well, we have a positive times a negative, so that's a negative. And then we have our 2's that reduce to 1 and our 3's that reduce to 1. So their product is -1. So perpendicular lines have opposite reciprocal slopes, and their product is always -1.